Let's continue our examination of example 2, the group of symmetries of the square. So in the previous video we saw that this group is called the dihedral group D4 and that it consists of 4 rotations and 4 reflections. So we have our 4 rotations that are described in the left column over here, and then we have our 4 reflections that were described on the right hand side of our examples on the top of the page. Now that we know what we have, so we have those 4 rotations, we have those 4 reflections, next is what is our binary operation on this set? We have our set, but a group also needs an operation, so what is the operation right here? Each of these 8 elements in our set describes a motion of our square. So a way that we can move the square around without really having changed what it looks like. It still looks like a square in that same position. The operation on these elements is combining motions, composing motions, if you will. So performing one motion followed by another motion. And let's look at a few examples. So what if we did a 0-degree rotation and followed that by a 180-degree rotation? What would we get? Well, the 0-degree rotation doesn't change our square at all, and then we rotate by a 180-degree rotation. That is the same thing as just performing a 180-degree rotation. And we can look at another example just involving rotations. What if we took a 90-degree rotation and then let that follow by a 180-degree rotation? So if we rotate by 90 degrees followed by 180 degrees, that is the same thing as rotating a total of 270 degrees. So for both of those examples, we can see that taking one of our motions, one of our symmetries, followed, composing it with another one, we again find one of our elements in the group. Now you saw me write backwards, so we were reading this backwards. We first wrote down the 0 or 90-degree rotation on the right, and then we moved left backwards from how we usually write. But this is very much like we use function notation. So this is just what we do when we use function rotation. And we will do that in this example. Let's look at 2 other examples that involve rotations and reflections together. So if I do first a vertical reflection followed by my 180-degree rotation, what do I get? Let's see, I need a little bit of space. So let's draw this out. I have my square labeled ABCD as we did before, and let's see what happens when we do a vertical flip, a vertical reflection. So we are reflecting about this vertical line. Then A and D flip, so D and A switch roles, and B and C do as well. And so this was our vertical flip, our vertical reflection. Now what happens if I do a 180-degree rotation? And you see what I mean when I say backwards? So we first do the vertical rotation, the vertical reflection followed by the 180-degree rotation, but that is written as R180 circle V, so the V happens first. Okay, let's see. So how should I label my square for the 180-degree rotation? Counterclockwise. Remember, this is counterclockwise. So A was in the upper right, now it's in the lower left. B was in the lower right, now it's in the upper left. C was in the lower left, now it's in the upper right. And D takes on the last corner right here. So I have my new labeling right here. And so I still have my square, just the corners are labeled differently. I can go back to my list of 8 things up here in the upper right and see, so B, A, D, C in that order, what is that? Let's go up here and see if we can find it. So B, A, D, C is right here. So apparently, first doing a vertical flip and letting that follow by a 180-degree rotation is the same thing as just having one horizontal reflection. We could also just have taken our original square with the original labeling, done a horizontal reflection, and come up with our end result. So that means that R180 circle V is the same thing as just our horizontal reflection. I want to do one more example, so let me make a little space right here. I want to do a diagonal, oops, different color. I want to do a diagonal reflection followed by my 180-degree rotation. So what is that? And you may want to pause the video and try it yourself and then watch what happens if your result agrees with mine. But I start with my square again in the original order, and then I'm first going to my diagonal flip, and then I'm going to do my rotation. So my diagonal flip, it was D is this diagonal right here, and A and C stay put, and then D and B change roles. Okay, and now I let that follow by a 180-degree rotation, and what do I get? See, A was in the upper right, it ends up down here, and then D goes there, B goes, oops, nope, that's not where B goes. I need to fix that. B goes down here and C goes up there. And then again, we want to know, could we have done that just with one symmetry, one motion? We sure could. If you go up to the list, can you find it? There it is. So it seems like the composition of D with R180 is D prime. So this is D prime. Now we can do this with any combination of our 8 symmetries. That is a lot, and doing this one by one would be very disorganized. So one nice way to organize all our group operations is in form of a Cayley table. So a Cayley table, that's the name, and that is that big table at the top of the page in our example. And the way we read it is we take, let me look at one example. So our first example, R0 and R180 that we did, that is right here. So we write it down with row, circle, column, and then we perform it by doing the operation in the column first, followed by the operation in the row, just as we did in example 1 right here. So we can fill this in, we already did the work. R180 circle R0 is R180. We already did this. And then our second example would be the entry right next to it. So that is, I'm going to do that in red. So R90 and R180. That is this entry right here. We already computed that. That is R270. And then what else did we do? We did that vertical followed by the rotation with 180. That is the entry over here on the right. So that is H. So that is this one right there. And then we also did the one next to it. So we filled in this entire row. This is D prime. You can pause the video, you can do the other ones, and I highly recommend that you do that, and you will find that this entry right here, so we need to fill in a V circle with everything else. We get a vertical flip followed by D prime, followed by, this one is R0, and then we have R270. And you can convince yourself that this is the case, and looking at the notes, you will find that as well.